We're recording. All right, so what I plan on doing today for this review, I had a couple students ask me if I was going to post my normal review exam or practice exam. And if you think about it, it's not going to work because you're not taking an exam like we normally do in the classroom. So what you're actually doing is you're taking an online exam. So what I decided to do today is actually open up, share my screen with you and show you the types of problems that you can expect to see on your exam. Your exam is on Monday afternoon at 2:30. Just a reminder that it is a 50-minute exam. It will start on time, and after 50 minutes, it will shut off. So just make sure that you have your exam submitted. If it starts at 2:30, it'll shut off at 3:20. You have until 4 o'clock to submit your scratch paper. So just a reminder about the scratch paper. You will not get the exam score if you do not submit your scratch paper. So the scratch paper and the exam score go hand in hand. Right now I have a pre-calculus student who he received I think a 70% on the last exam we took in pre-calculus, but he currently has a 0, and it will remain a 0 until I get the scratch paper. So just remember to turn in your scratch paper after you finish the exam. It could be 1 page, it could be 10 pages. I need to be able to see it. I think I mentioned the other day, make sure you write the original problem, make sure you number it, make sure you write vertically, make sure you write darkly, make sure you circle the answer. All right, okay, so what I'm gonna do now is I'm gonna share my screen with you and we're gonna go into my HRW. I did a little bit of this when in my initial presentation. The welcome presentation. So just to review, I don't think anyone's having trouble getting into my HRW. But one way to do it is to go to make sure you're using your school Gmail. You go into the Colton High School homepage, you go to Let's Go, you go to Class Link, and you'll see a whole bunch of apps you want to click on My HRW. Then sign in. So your screen will look a little different than mine. I have a bunch of boxes all over. I'm going to try to get rid of these boxes. Just bear with me. There we go. Move this somewhere else. Okay, I'll wait until I see it. Your screen will look something like this. This is my screen, so of course you're not going to see the teacher resources, but you're going to always go into your interactive student edition. In this last module we've been working in, it's been Unit 6 for the online problems. I'm going to go into 15 right now. That test exam is on 15.1, 15.2, and I'm going to go into 15.1 right now. So this is where I recommended you go in the welcome presentation. There's a lot in here, but this is the key arrow right here that you're going to pick. So like I was mentioning in the opening presentation, the welcome presentation, that evaluate. This is all a teacher teaching the lesson if you want to see another teacher teach it. But this evaluate is what your textbook problems look like. It also looks like the exam problems. So you want to make sure that whenever I assign the evaluate for the online problems, you want to make sure that you do these because this is what will look like the exam. I'm going to sway away from this for just a second and go back over to resources. This is also very valuable because you see your Teach Student Edition, which looks exactly like your book in the cupboard at school. You also see a practice exam AB, which were the sheets that I gave you when we were in the actual classroom. And then the student resource locker is valuable because there's a lot of videos and there's different things in here that you can use that are useful, including the student edition, the interactive student edition, And I think there's selected answers in this student resource locker. Go back to contents, and we're going to look at evaluate, and I'm basically going to tell you what types of problems are that you can expect on this exam. So this problem wasn't that bad, but I did not put it on the exam because I did not want you to make a table. The way we're graphing the logarithms, we're graphing 2 points. We know what the logarithm looks like. We know that there's a vertical asymptote at x equals 0. And so I did not put a problem like this on the exam. I hope you all are doing this. I have asked you and tried to hold you accountable for this, that you can look at examples of problems. You can look at step by step, which some people have been having trouble with because if you make too many mistakes, it will kick you out. That's not the software problem. The software thinks that you're messing around with it. So what I would do is make sure you know how to do the problem. Don't just be putting in random things and testing out the software. Do the problem. You might have to go back and enter in again so that you can actually put in the correct answer. So there's a lot of different things that are helpful here. I recommend that you play around with them if you haven't already. Let's go to problem number 2. In this problem, there was a lot of different things in here. I actually really like this problem, but I did not include it. The reason why is because it's asking about writing the domain and range in set notation, and you should be able to do that. But I'm not requiring that. I want things in interval notation. There's also other things in here. The X and Y intercepts, which we've been writing as ordered pairs, the in behavior, positive and negative, increasing and decreasing. You should know how to do all that. We did that the first week of class in August, but because of the notation that the software is requiring, I didn't want anyone to actually know how to do something but get expelled from the exam or something because you're not using the notation that the software is particularly looking for. So I didn't, even though I like this problem and you should be able to do it, I excluded this problem also from the exam. Let's go to number 3. This problem I skipped. Number 4, this problem I skipped, once again because of the set notation. Number 5, you have to know how to do a problem like this. So when we're finished going over this, what the exam actually looks like, I'm going to work some problems for those of you who want to see problems, but you need to know how to do this problem. And you need to know how to do it online. Number 6, same thing. You must know how to do this problem. This is on the exam. Number 7, you must know how to do this problem. Number 8, you must know how to do this problem. Number 9, you must know how to do this problem. Number 10, you must know how to do this problem. Let's go on over to the next set. Number 11, you must know how to do it. Number 12, you must know how to do it. It's all similar, right? Okay, this next problem is a new problem where we're asking for 3 different answers, and it was asking you to evaluate these different values. So in this case, they want you to evaluate 1024, they want you to evaluate f of 1 over 64, and they want you to evaluate square root of 64, which you should write as 64 to the 1/2 power. You want to make sure you know how to do this problem. If you don't know how to do it, you want to ask me about it. But yes, it looks exactly like this on the exam, and you must know how to do this. Number 14. You must know how to do this problem. Looks exactly like the problem we just saw in 13. Number 15, you must know how to do this problem. Number 16, okay, a different type of problem, and you must know how to do it. So you must know how to evaluate log base 10 of 16 and the natural log of 16, by using your calculator. More importantly, you must know how to round the way they're asking. If you do not round properly, I specified this when I defined it, that if you don't round properly, you'll get points off. So you must round properly. Make sure you know how to do it. At this point, you should know how to round. We've gone over it a zillion times. Round correctly. Number 17, that will be on the exam, just like 16. Number 18, that will be on the exam, just like 16 and 17. Number 19, it will be on the exam. Number 20, yes, this is the one word problem that you need to know how to do. So I did give this a couple of different ways in your textbook. I did give it on this online evaluate, and you need to know how to do this problem. Pretty simple. You should know how to do it. Hopefully you can do it. All right, let's go to 21. I'm not giving this, and I'm not giving 21, 22, 23, 24, 25. So don't bother with those. All right, you just need to be concerned as far as application problems go. You need to know how to do problem number 20. So forget 21, 22, 23, 24, 25. Okay, I'm going to stop there for 15.1. Does anyone want to unmute yourself and ask me about the exam that will cover lesson 15.1? Questions? All right. Let's look at 15.2 then. See if I can get back to it. Oops, something is not working. I'm gonna get out of this. Hopefully. Come on, you can get me out. No, it can't. So I'm just gonna close this. I might have to go back, and I do. Not a big deal. I'm back in the interactive student edition. I'll go to 15.2 this time. Once again, you want to go to this arrow. And we're going to go down once again to evaluate. All right, here we go. So in 15.2, you were mainly asked to graph logarithmic functions. So you need to know about the parent, you need to know about the parent points, you need to know the transformation order, you need to know how to transform the points. And so I'm just letting you know these problems look a little bit different than what you're used to seeing with me. These are more Common Core-like, but you should be able to do them. So you should be able to do this problem, in my opinion. What they're doing is they're giving you 3 graphs, and they're asking which color goes with who. So who goes with log base 7? Who goes with log base 10? Who goes with log base E, which is the natural log? So what you're going to do is you're going to put in the appropriate X and get 1 out for Y and give the answer. So there is a problem like this on the exam. Just to recall that the value of E is a natural logarithm and the value of E is about 2.7. Make sure you know how to do this problem. Let's go to number 2. All right, so this is asking you to describe the attributes of those logarithms in common and the attributes that make them different, attributes compared with domain and range, the end behavior, this and that. So they're asking, see this? Average rate of change. I did not include this problem. Okay, I'm not interested if you can find the slope right now. I just want to know, do you understand the concepts in this lesson? So once again, they're using set notation. You should know how to do this, but I didn't include this on the exam. Let's go to number 3. All right. right, you need to know how to do this problem. You know how to do it. Let's look at it. They're giving different functions. And if you read below, it says the graph of G is a vertical translation down what? So somebody tell me, unmute yourself. Down what?
5.
Yeah, right, down 5. Don't put -5. Okay, it's not down -5, it's down 5. So you would put 5. The down, this word right here, is the negative. So you would say down 5 units. Let's go to the next one. The function g, 8 times log base 2 of x. The graph of g is a vertical stretch of the parent by a factor of what, ladies and gentlemen? Somebody unmute yourself and tell me. 8. Exactly. So you would put 8 in there. Let's look at the next problem. Another g function, log base 2 of the quantity x plus 4. The graph of g of x is a horizontal translation. That's the h value of the graph of the parent left what?
4.
4. Really hard, right? So you guys were all stressed out about nothing. This is easier than the exams I give. Let's take a look at the next one. Another g function, -3/7 times log base 2 of x. The graph of g is a vertical compression of the parent by a factor of what?
3/7.
7.
Negative. Oh yeah, 3/7. Okay, now, here's the deal with this, okay? Yeah, it is 3/7 because look what they say below. See, I was afraid they were going to put -3/7, but it is 3/7 because look what it says, as well as a reflection. So I'm really glad they did that. That's how I taught it. Yeah, 3/7 and then as well as a reflection. You know what? I'm still a little scared about this. Matthew Sosa or somebody who did this, did it accept -3/7 or did it only accept 3/7? I'm scared about the software right here.
3/7 worked, but later on in some problems, I know it'll ask you to put it as a mixed number, not an improper fraction.
Okay, this isn't, yeah, this is a proper fraction, so we won't talk about that right now.
It
But let me just,
It doesn't accept -3/7.
okay, good. All right, doesn't accept, and it shouldn't, right? Because the vertical compression is 3/7, and then, you know, it's the reflection. So, okay, thank you for sharing. So you're just going to go through this. Does anyone want me to finish this, or I'm gonna go on? Speak up now if anybody wants me to finish this. Let's go on then. Problem number 4. All right, now there is a problem like this. There's a couple maybe on this exam. It's a little different than what you're used to seeing because they're skipping. See where my arrow is? They're skipping a few. They're doing a, they're doing a vertical stretch by 3 and reflecting and then adding 2 all in one step. But you don't have to do it all in one step. You can do it on a piece of paper and then answer the question. So other than that, this problem should be fairly simple and you should know how to do it. So this is how they're going about, you doing the graphing on an open-ended question. This is how it looks like online. I cannot throw this out. So here's the function. You want to read through the problem and fill in the boxes. And then you're going to fill in this box for these points for the parent. Right 1, 0, right 2, up 1. I do realize that they are asking for the domain and range in set notation, but I was not willing to throw out this problem because of this one little section, especially since you should know how to do set notation. So I did include this problem. You are required to answer the parts and do the problem, and you might see 2 or 3 of these. Let's go to number 5. Same thing. You must know how to do the problem. You must know how to fill in the boxes. You must know how to fill in the table. You must know how to do domain and range and set notation. And I think you do have to pick the appropriate graph. I personally don't like these graphs. The reason why is because they should have shown the parent dotted. Unless they asked you at the beginning, I didn't read it that closely. If they ask you to graph the parent, then it should be solid. If they did not ask you to graph the parent, which in this case is the red one, if they did not ask you to graph it, it should be dotted. So whatever they asked, if they asked for both, then it is correct. But notice what we've talked about this. Notice how there's no arrows. Those graphs are actually incorrect because we know that these graphs should have arrows on them. There should be an arrow here going down forever. There should be an arrow here going up forever and right forever. There should also be an arrow here going down forever, but not crossing the asymptote. And there should be an arrow up here. So you should know that. We've talked about that before. Okay, number 6. Same problem. So same type of problem. Fill in the blanks. Pick the graph. Number 7. Come on, give it to me. Same type of problem. This time you're working with the natural log base e. So notice down here where my arrow is, see the e for x? We know that's approximately 2.7. We didn't do it like this, but that's okay. You know it's 2.7 plus 2. So you should be able to acclimate to what they're doing. It shouldn't be a big deal. If not, you need to practice more. Same thing. Make sure you know how to do these problems. Number 9. No, we didn't do this. In fact, if I'm not mistaken, if you look at your assignment, I didn't even assign these. I didn't assign any applications in 15.2. So that's a no. Number 10, no. Number 11, okay. I'm not sure if I included this one. I might have. This is just general knowledge, you know, about A, B, H, and K. So there might be a problem like this. I'm sorry, I don't remember. So I can, that's okay if you don't know. I would actually look at this and know how to do it. Number 12. No, I don't think I assigned this, and I don't think I gave it. I did not. Not included. Number 13, not included. All right, so with that, anyone want to ask me any questions about what's on the exam? Okay, I hope you're feeling a little less anxiety, especially for those who have been going through the online work. You should be feeling no anxiety whatsoever. What I would do is I would go over it, make sure you know all the little different parts. You know, I would go over it again, go over it again and possibly go over it again and make sure that you feel very comfortable about the evaluate. So that's what your exam looks like. All right, I'm going to stop sharing my screen with you. I'm going to pin me for a minute. Hold on just a second. All right. Let me get out of this, please. Hold on. So from here on out, I would like to take questions if you have any about those types of problems or any questions about the online work. I know there were some questions about the 3-part problem where you're having to evaluate. You want to make sure your calculator is in the right mode. What mode should your calculator be in? Anybody? What mode should you be in? Just in our regular mode, right? I mean, we're not doing anything special. All right, so I'd like to open this up now to the whiteboards. I'd like to work some problems if you want to see any. Just a reminder that you are required to come to class meetings on Monday and Thursday. You do not have the option of watching the video. That's in addition to coming to the meetings. You must take this exam on Monday at 2:30. If you miss it, you get a 0. So unless there's an extenuating circumstance that you talked to me about, or there is some type of emergency, you are required to take that exam on Monday at 2:30. It is not easy for me just to give an exam just anytime I want. There's a lot involved with defining the exam. For people who are taking another time, I would have to write another exam for you, because being online, you're capable of taking screenshots and sharing those. So it's not an easy thing. So everyone is expected to take the exam on Monday at 2:30. Make sure that you realize it's only 50 minutes. So don't come in late. Come in on time. I've been trying to get you to get in a routine. I would get up like you normally do for class. I would take a shower if you normally do. I would brush my teeth. I would eat a little breakfast, whatever. But I wouldn't just roll out of bed and take the exam, at 2:30. I wouldn't do that. I'd make sure that you're ready to take it. So be prepared to take it. All right. Any questions? I'm going to unplug this. Sorry about all the light. I have a lot of windows in my house. So I'm going to be moving my laptop now to the whiteboards. Anyone want to ask me any questions about the bookwork or the online? Anybody want me to work any problems?
Could we work problems like 15 and like 20 from the online 15-1?
All right. Can you guys see the boards? I have my book open right now, so if you could focus on that. I don't have the online, I don't have access to it right now because I'm talking to you. So Matthew, were you talking about number 15 in the book? $15 or $20 in the book, anyone? Or Matthew, was that one you were talking about or no? Okay, somebody talk to me, we're wasting time here. So one thing I'm not gonna do in these reviews and workshop, I'm not gonna waste time at all. So you should come prepared with questions.
Yeah.
So anybody have a question about something? Go ahead.
Yeah, problems like 15.
Okay, which one would you like me to do?
Can we do 15?
All right, for everyone else, this is in your textbook on page 756. These are notes you took home with you, so you should have them. Okay, in problem number 15, do you want me to do all 3 or do you want me to do 1? I can do all 3. I am going to do them different than the book. So I taught this differently and I'm going to do them differently. So maybe we should do all three of them. So let's start with f of x being, they're wanting you to evaluate f log base, what, 1/4? Of x. Yeah, that's the function. And they want you to, that's the function. They want you to evaluate f of 1/64. So that'll be the first one we do. Is everybody okay? I'm the right problem, if I've written it down right. So what you're going to do is wherever you see an x, you put 1/64. And the way I taught this was to get this number to match the base. So in other words, we want 1/4. We want 1/64 to look like 1/4. We can't make 1/4 look like 1/64. You have to make this look like 1/4. So the reason why we're doing that is so we can use the property, the inverse property log base b of b to the x equals x. So I'm trying to get the base of the logarithm equaling this so I can say that x equals x. So isn't 1/64, isn't that 1/4 to the third power? Because 1 times 1 times 1 is 1, and 4 times 4 times 4, isn't that 64? So what's log base b of b to the x?
3. Because the b's will cancel.
What's that?
No, because the b cancels the 1/4, right?
Yeah. It's like they undo each other. So the base of the logarithm and the base of the exponent, they cancel each other out. They're inverses. So you can think of it that way. I really don't like when people do this, but you can think of it like that. The base of the logarithm and the base of the exponent are inverses and they cancel each other out. This is an inverse property. All right, can I erase this? You have this written down, right? I'm going to erase this. It's a very important property. Use it a lot. If you don't know it, it's going to be a big problem for this exam. All right, let's do this B part in 15. It's wet. Right off. Okay, the B part is what, f at 256? Base 1/4 of x. So once again, wherever you see an x, you're going to put 256. But the parentheses are not, they're redundant. All right, now, we have to make 256 look like 1/4. Well, don't we have to flip it eventually? So if we have to flip it, I don't care when you do it, but we're going to have to get it on the bottom somehow. And when you do that, don't forget to put -1. So that goes back to the negative exponent property. X to the -1 equals 1/x. In the same way, I went backwards. I went this way this time. 1 over a number. When you put it back up to the, when you put it back up or down, you have to put the negative exponent. So when I flipped it, I had to put the negative exponent. All right, so now, please tell me that 256 can be reached with 4 to the something. 4 to the what?
To the 4th.
I'm going to put that in here because I'm going to keep that -1 out there. And so you see how 1/4 to the 4th equals this, and my -1 power floated down. So now I'm going to multiply the powers. So I get 1/4 to the -4 by using the power property for exponents. So now log base b, this is a subscript. log base b of 1/4 to the -4 is -4. This is a 5-step problem. I would not try to do it in any less steps. People who try to do this in 1 step always get it wrong. So I'm warning you, make sure that you let the problem and you use properties appropriately and let the problem work its way out. If you try to do this in 2 steps, good luck. Can't guarantee you're going to get the right answer. Any questions about this? Anyone? Let's try the last one. So people are lucky today that I'm recording this. I'm not recording these in the future. I'm not planning on it because I don't want people to get lazy. You know, I want people to attend when I make things available, and you need to make it a priority. So if your family is forcing you to do something, I understand that. But some of you have got to talk to your parent or guardian and say, listen, she's going over something. Can we go when she's done? Can we do it some other time? Is it possible? Because I have to be there. So some of you aren't doing that, and you need to ask your parents, is it okay if I go to her review? Is it okay if I go to her workshop? You know, this is important. It's like me being in school. You're expected to be, well, today's Saturday, but during the week, you're expected to be in school. So I do realize that there's things going on at home. I do get that. I do realize that a lot of you would rather be at school than be at home. I do understand that. I get it. So there's a lot of different things going on at home that you're not particularly interested in. And I understand that. So anyhow, but I want you to make every effort to be in the things that I'm doing. All right, let's go to C. Okay, this is the one that a lot of people didn't know how to do. Okay, this is F. What is the cube root of something? 16? Is that correct? Yes?
Yeah, that's correct.
Okay, thank you. So wherever you see an X, okay, so now, wherever you see an X, you're going to put the cube root of 16. Well, that looks nothing like what I want. So the first thing we're going to have to do is get rid of the radical. So if you get rid of the radical, wouldn't this be 16 to the 1/3? I'm just going to put it outside. I can put it inside or outside, however I feel, right? Is that correct or no? So in the past, I've told you, don't change radicals to rational exponents. Don't change rational exponents to radicals. Don't do that. But now we're forced to. In this problem, we're forced to, because I'm teaching this using the properties of logs. It's not taught until 16.1, but I wanted to expose you to this because it's easier than what the book's teaching right now. All right, so how do you make 16 look like 1/4? Well, that's not going to do it. So we have to flip him. Now we have a negative exponent to the 1/3. A lot of steps. So this would be log base of 4 of 1/16 raised to the negative 1/3 power, multiplying powers, right? So now log base 1/4, can't 1/16 be written as 1/4 again? And wouldn't that be 1/4 squared to the negative 1/3? So wouldn't that, can you guys still see the screen if I write down? Here, I'll tilt it down. Log base 1/4 of 1/4 to the negative 2/3 power. And finally, the base of the log matches the base of the exponent, so the answer is negative 2/3. 6 steps. So 6 steps on this. Don't try to do it, in 2 steps. You're not going to be able to do it without making a mistake. So use properties, let the problem work its way down without messing it up. Okay, I hope that helped. If you did it like the book, that's okay. If you did it like the book, I'm just showing you how I would do it by using the properties. The properties make things easier to some extent. That's why we have properties. That's why we have definitions, to make things, that's why we have formulas, so that we can make our life easy. So this one wasn't great, but in most of the time, it's better to do it the way I'm teaching it now, because it's more simple. Any questions? Can I erase it? I'm going to tilt this back up now. Okay. Matthew, are you still around? Did you want to do another problem? You mentioned another one, or someone?
A problem like number 20 in the book.
Okay, there is a problem like this on the exam. This is on page, 757. I'll read it. The acidity level of pH of a liquid is given by the formula pH equals log base 10 of 1 over, it's the H plus, where that H plus is the concentration in moles per liter of the hydrogen ions in the liquid. What is the pH of iced tea with a hydrogen ion concentration of 0.000158 mole per liter? It's got some chemistry here. All right. Sorry about that. Let's write it down. So pH is equal to, what is it, log base 10 of 1, the hydrogen ion, log base 10, right? All right. So what are you going to do? They're saying, what is the pH? So pH is the variable, right? So pH is the variable. They better give you that. So are they giving you the concentration of the hydrogen ions in the liquid? Yes or no?
Mm-hmm.
Yes. So they're giving 0.000, was it 158? So just use your calculator. We're not doing this by hand. You see decimals like that, use your calculator. So you can just put it in your calculator in one shot. Now, I would put this in parentheses though, because if you don't, let me tell you what's going to happen if you don't. The calculator is going to take log base 10 of 1, and then it's going to divide by 0.00158, and that's not what you want. Okay, what you want is the log base 10 of that quantity. So if you don't use parentheses, trust me, you're not going to get the right answer. So you have to put it in parentheses, and you have to pay attention to what you're doing with the calculator. Remember, it doesn't have a brain. All right, so go ahead and tell me log base 10, parentheses 1 divided by that decimal, and what do you get approximately?
3.8.
Yes. Is it 3.8 exactly?
Yes.
Yes. So this would be a pH. The pH of the iced tea is about 3.8. Now, I don't know how they want you to write it on this exam. I usually have you write a sentence, but since I'm not, I'm having the software grade it, I think you just leave it like that. Really simple, right? All right, so that, we're talking about 15.1 right now. Are there any more questions about in 15.1? All right, I'd like to flip over to 15.2 then. I'll take questions on 15.2 now. Questions on 15.2? For those of you who are good at graphing, you should be good at this. You need the two parent points. You need to know there's a vertical asymptote. What moves the vertical asymptote is H, the left and right. And it's pretty much the same thing we've been doing since August. So we've been graphing lots of functions. And this is no different than what we've been doing. So, any questions about 15.2? Go ahead.
Can you do like number 1 that was online? The one where it said to match the the line to the function?
Okay, number 1, are you talking about the one that's on page 770?
Yeah.
Okay, I can do that problem, but I'm not going to do it now because it's not on the test. So I don't know if you were here earlier when I started this review, but I went through every single problem and said what was going to be on the test and what's not going to be on the test. And number 1 is not going to be on the test. So I don't want to focus on it right now. I take it back. Number 1 is the 3 graphs, right? I was thinking it was number 2. I'm sorry, Lucy, it's my fault. Okay, number 2 isn't going to be on the test. Number 1 will be. Okay, I'm sorry, Lucy. Let's take a look at it. All right. So sorry about that. On page 770, number 2 will not be on the exam, but number 1 will be. And they're asking you to graph these different functions. So you have f of x is equal to, what is, I can't see it, you guys, it's so small, log base 2 of x. And then they have f of x equals log base 10 of x. And then they have f of x is equal to the natural log of x. That is not an I, by the way, that's an L. All you do is just graph them the way we normally do. So the first graph, I'll do the graphs over there. F of x equal to log base 2 of x, that's a parent. So there's a vertical asymptote at x equals 0. And all the parents have a vertical asymptote at x equals 0. So the tricky part of this is, what do you pick for x? So let me hear from you guys. What x's would you pick?
1.
So you would pick 1 because log base 2 of 1 is 0. That's a property, right? Remember, log base b of 1 equals 0. Okay, give me another number.
2.
Right, because That's the property we just talked about a minute ago. Log base 2 of 2 to the 1 is 1. So once again, log base 2 of 2, when the base of the exponent matches the base of the logarithm matches the base of the exponent, it's the power, which in this case, log base 2 of 2 to the 1 is 1. That's it. Graph it. I'm going to do it in a different color. So I'm going to do this one in black. So this one, right 1, 0, right 2, up 1, and draw the graph with the vertical asymptote at x equals 0. So you run the graph along the vertical asymptote. So that's the black graph. If they ask you to state the domain would be what? Open on 0 to infinity. And the range would be all real numbers, which if you notice is switched from your exponential functions. So with the exponential functions, exponential growth and decay, the domain was all real numbers. Let's do the next one in blue. Log base 10 of x. Same asymptote. What kind of points do you want to pick now? Go ahead, I'm listening.
1.
Right. Log base 10 of 1 is 0. Back to that property. Okay, we want one more point. 10. Because this, remember, this is imaginary 10. It's invisible. Not imaginary, it's invisible. So you have log base 10 of 10 to the 1 is 1. If you don't understand that, ask me now. You're not going to figure it out later. So ask me now. So log base 10 of 10 to the 1 is 1. Anybody want to ask me about it?
So as long as we get the bases to match, it's gonna be the exponent.
Yeah, because
Okay.
watch, you have log base b of b to the x equals x. So if you get these bases to match, they're inverses. The base of the logarithm is the inverse of the base of the exponent, and they cancel each other out. So back over here, see this log base 10 of 10 to the 1 is 1 by this property right here. You understand what I'm saying or no?
Yeah, thank you.
You're good? Okay. Well, yeah, thanks for clearing it up for everyone else, Lucy, because there's about 20 people that don't get it. So thanks for being bold enough to ask. All right, so we go over here to right 10, 2, 4, 6, 2, 4, 6, 7, 8, 9. Is this it right here, hopefully? Right 10 up 1. And then we have right 1, 0 again. This one. So now we're seeing when the base of the logarithm is bigger, we're seeing that type of graph. When the base of the logarithm is smaller, it's got more height. Let's use another color now for the natural log. So we have f, that kind of looks black. Hold on. She's pink. Natural log of x. Okay, once again, you have a vertical asymptote at x equals 0. Tell me what x you're going to pick. Got this thing?
1.
So and remember natural log is log base e. So what's log base e of 1? Just like this one. This is true too. Natural log of 1 equals 0. Same thing. This is log base e. It's the same definition. So pick another x,
2.7.
right? Right. E is about 2.7. So when you have log base e of e, what's log base e of e to the 1? Log base e of e to the 1.
1.
1. So on this one, once again, you have right 1, 0. You have about 2.7 up 1. Mark a little bit, it should be up a little bit. 2.1, up 1 is up there. So do you realize that on all these problems, the domain and range is the same? So this one, the domain is 0 to infinity, all real numbers. On this one, 0 to infinity, range, all real numbers. So the domain and range is the same on all of these. Okay, I think Lucy, you asked about this, right? Lucy, you okay with this?
Yeah, I just wanted to make sure that I was like showing the work correctly.
Yeah, I know. You get it though, right? You're okay?
Yes, thank you.
All right, you're welcome. Anybody else want to ask me a question before I erase this? All right. I'm actually going to stop the recording. I don't want the recording to be 5 hours long. So I'm going to stop the recording and I'll take more questions.